we construct the graph of the function y equal to 2x minus 5 when x is less than or equal to 0, and to x squared minus 5 when x is greater than 0. Now, the graph of y equals 2x minus 5 is a straight line. We can easily find its x and y intercepts. If x equals 0, y is negative 5, so the y-intercept is negative 5. And if y is 0, x is 2 1/2, 5 halves. So we have the two intercepts. We can draw the straight line through those two intercepts, and there's our graph of y equals 2x minus 5. And the graph of y equals x squared minus 5 is just downward shifted from the familiar graph of y equals x squared. So now it's going to look like this. Right here, very likely, is a graph of y equals x squared with its points 0, 0, plus and minus 1, 1, plus and minus 2, 2, 4. Okay, and so we easily get that graph, shift it down, each point down 5 units, sketch the curve. Now, the graph of 2x minus 5 applies only when x is less than or equal to 0. So it only applies up to the y-axis, which is where x equals 0, and then the other function applies. Now, fortunately, both of these functions have the same value, negative 5, at x equals 0, so that the two graphs actually meet. If this will always be the case. If this was x squared minus 4, then this parabola would be 1 unit higher, and this graph wouldn't meet this graph. There'd be a gap here. But in this case, the graph moves on continuously, so that for positive values of x, we follow the parabola. Okay, so the green graph represents the split definition function. We add that when x equals 0, 2x minus 5 and x squared minus 5 both have the same value, negative 5, and it follows then that the graph is what we call continuous at 0, negative 5. At this point, where the two split definitions meet, the functions would have the same value, so that the graph continues in a very smooth fashion. No, I wouldn't call it smooth. The graph continues without interruption, without a break of any kind, and we call it continuous at that point.